In the next three examples, we'll take a look at using the product rule along with some properties of algebra. So we'll first start off by rewriting the given function and then differentiate from there. We can rewrite this function as 5 times the natural log of x using properties of logarithms times e to the x minus 3x. And then we can identify our two functions in the first term, and then in the second term we just have a single function, which will just be a simple differentiation step. To find c prime of x, we'll take the derivative of 5 times the natural log of x, which will give us 5 over x times e to the x plus 5 times the natural log of x times the derivative of e to the x, which will be e to the x, minus the derivative of 3x, which will be 3. And then we can just merge some of this a little bit together a little bit to write this as 5 times e to the x over x plus 5 e to the x times the natural log of x minus 3. We didn't really do much work there, just rearranged and merged some of the factors a little bit. In example 6, we can rewrite this first term as x to the 4th times the natural log of 2 plus the natural log of x using properties of logarithms minus 5 e to the x. Distributing x to the 4th through, we get x to the 4th times the natural log of 2 plus x to the 4th times the natural log of x minus 5 e to the x. Looking at the first term, the natural log of 2 is just a constant value, sort of just a coefficient there, so that's just a simple derivative step. 5 e to the x at the end is a simple derivative step, but in the middle we have the product of two functions. So in order to find d over dx of p of x, we'll have to apply the product rule to that middle term. But first we'll take the derivative of x to the 4th, which will be 4x cubed times the natural log of 2 plus 4x cubed times the natural log of x plus x to the 4th times 1 over x, and then minus the derivative of 5e to the x, which will be 5e to the x. In our third term, that x in the denominator will reduce with 1x in the numerator, so we get a little bit of simplification here to get a final result of 4x cubed times the natural log of 2 plus 4x cubed times the natural log of x plus x cubed minus 5 e to the x. In example 7, we need to again use some algebra properties to rewrite this, which we can rewrite as the natural log of x times e to the x times e to the 3rd power plus x to the 4th. In the first term we have two functions to differentiate, and in the last term just a single function. So when we find dr over dx, we'll take the derivative of the natural log of x, which will give us 1 over x, times e to the x times e cubed, plus the natural log of x times the derivative of e to the x is just e to the x, and e cubed is just a constant, so the derivative doesn't affect that at all, plus the derivative of x to the 4th, which would be 4x cubed. Now we can merge those exponentials back together by adding their exponents to give us e to the x plus 3 power over x plus the natural log of x times e to the x plus 3 power plus 4x cubed.